constantly interrupted by dogs. But I want to cover this video. I was asked about convexity, okay? And this example covers that topic. Specifically, Macaulay convexity. I've been told it's Macaulay, so I apologize for butchering your name before Macaulay. Apparently, that's what you're supposed to call him, okay? That's his name. Anyways, these are the details of the question, and we're given the present value of the liability cash flows, and I think you just think of it in terms of price. These are the price right now of the cash flows in the future. So I have that listed here, 9697. I have the Macaulay duration, which I've labeled as MACD sub L to correspond to the liabilities, and it's 15.24. And then finally I have the Macaulay convexity. Now, one interesting thing, just a side note, is that I haven't seen Macaulay convexity really in any textbooks. Actually, the only textbook I've really been looking at is the ASM. Haven't seen it in there at all. So I will say, though, ADAPT covers it. I'll write down the formula for that. So before I continue, well, let's just continue with what I have. I have the following assets, and they're given as zero coupon bonds. So here is the redemption value of the zero coupon bond, X, and it has at time 5, right? So I need to discount that, v to the 5th. I have a zero coupon bond, a 15-year zero coupon bond, and a 20-year zero coupon bond. All of this, I'm using the underlying interest rate of 7.5%. Wonderful. Now, if you want to get right to what I'm going to do for the answer, just fast forward. I'm just going to talk a little bit about convexity. Okay, I'm going to write down two formulas. The Macaulay convexity versus just convexity. And if they say convexity, it's assumed to be modified convexity. Kind of annoying because if they just say duration, it's assumed to be Macaulay duration. They would specify otherwise if it was modified duration. So, let me first write down something that we will need. We need the Macaulay convexity for my assets. And by the way, we need to choose two of the three, so we'll talk about that in a minute. But first off, what is Macaulay convexity? Now this, maybe the easiest way to think about this, or to actually arrive at this, is that it's the second derivative of your price with respect to delta divided by your price evaluated at delta. Sorry, the second derivative of the price evaluated, well, thinking of delta as your independent variable, the thing you're differentiating with respect to, and then we're going to take the price just in terms of delta. But really this is the price, right? And these are going to be numbers. Now what you would get if you wrote out the price in terms of delta, I think it's going to look confusing. You need to convince yourself of this. But let me just write it out and I'll tell you what I mean, okay? Now what you would get is this. You get some sum, okay, and I don't care what the indices are. I don't care what I'm summing over. Just imagine I'm summing stuff. And what am I summing? I'm going to be summing t squared, v to the t, and rt. rt, these are just my cash flows at time t. Sometimes you can write this as cf sub t, cash flows at time t. v of t, of course, is my discount factor. T squared is just time squared, wherever the cash flow is present. So at time 5, this would be 25, right? Okay, divided by just the price of the cash flow. So just sum up all my cash flows, right? So V, just the usual thing. Now I want to just mention a few things, just one thing really, to distinguish this from just modified convexity. Okay, if you think about, if you're going to differentiate price with respect to delta, what I would do personally, if you just imagine replacing these V's with expressions in terms of delta, you would be having exponential e in here. And I differentiate e, right, with respect to delta, okay, just imagine here, I have some sort of e to the delta thing floating around. If I differentiate this, right, the delta is going to be the only thing that basically, the t is going to be the only thing that comes out and differentiate this respect to delta. With respect to delta of this, think about the first derivative. It's just t e to the delta t. That's where I'm getting these t's from. If I differentiate again, I get t squared. So just be thinking that's where this comes from. Okay, these are some expressions. These are some pieces of my price function of delta. So that's hopefully gives you an idea of where we're getting the Macaulay convexity formula. Now, how does that change when I look at just modified convexity? They're not asking about modified convexity, but it's important to distinguish between the two. Mod C is given by the second derivative of price with respect to the interest rate divided by the price as a function of the interest rate. So this is very similar in terms of what I'm going to be thinking about for computing it, but the formulas is quite different actually. Well, it's different enough that it needs to be mentioned. It's t times t minus 1 times t v to the t plus 2 rt all over. Now this denominator is exactly the same, so it's just v to the t rt. RT plays the same role, still the cash flows at time t. Now why am I getting a different formula here? I'm taking the second derivative again, but I'm thinking of it with respect to I now instead of delta, right? So things change. If you think about this, go through this again. If I take some derivatives of this v portion, okay, I'm thinking of v as the usual 1 plus I to the negative 1. Use the power rule. T's come down, subtract 1 from the exponent, but be careful. Excuse me. When I subtract it from the exponent's already negative. That's why I'm basically adding this. Go through that argument. Convince yourself as to why this is right. So I have Macaulay convexity, modified convexity. Those are the formulas. In this case, I'm only interested in the top one. All right, that's my spiel about that. Let's get back to the question. So, the question asked me to only use 2 of the 3 assets. Now, I want to point something out. First of all, they give me several options, and they only encompass potentially 2 routes I could take. We're either going to use, and this should make sense to you, and I'll say it in a minute, we're either going to use this guy and this guy, or we're going to use the 15-year and the 20-year. Now think about this for a second. The liabilities have duration, a Macaulay duration of 15.24. That tells you, you should be thinking, there's absolutely going to be a cash flow in my liability portion that's after 15 years, so assuming they're years. It's 15.24. There has to be some cash flow greater than 15. So that should indicate, I mean, if we want this to actually be immunized, in this case I think it is Reddington immunization, then we do need, hopefully, for things to be satisfied, we're going to need a cash flow which is later than 15 years. So we're using Reddington. So, what are the requirements of Reddington immunization? Okay, I'm going to write that down as well. So again, if you want, fast forward. Okay, so requirements. We need 3 things. And in this case, a lot of times you only need to check 2 of them, but in this case you do need 3. So number 1 is we need the price of the liabilities to equal the price of the assets. Number 2, we need, and it doesn't matter whether it's modified duration or Macaulay duration, it doesn't matter. So I'm just going to put the duration, this is sometimes the notation I use, duration of liabilities must equal the duration of the assets. The third thing, for Reddington immunization, this is where things change actually between Reddington immunization and full immunization. For Reddington immunization here, what I need actually is, I need something to do with convexity. So I need actually that the convexity of the assets is actually greater than the convexity of the liabilities. That's what you need there. If this was full immunization, what you need is you need a cash flow for the assets. One of them needs to be greater than the last cash flow with regards to the liabilities, and one of them needs to be less than the smallest cash flow. So you need sort of, assets have to have cash flows on each side of the liabilities. All right, that's a separate topic. So these are the requirements we need to satisfy. Now let's go through the question finally. Man, I take forever. How annoying am I? Jeez, you guys just must be sick of my crap, right? All right, so let's see what we can do. And by the way, I'm just gonna go with honestly what I went with the first time, and that is I'm thinking that I'm gonna need 5-year and 20-year zero coupon bonds for this to be satisfied. That's honestly what I did the first time, and it happened to work. If it didn't work though, I just tried the other alternative. So let's write this down. Let's first write down the price of my assets. P sub A, the price of my assets. Well, they're going to be, well, I have this 5-year zero coupon bond with redemption value of X, plus I have this 20-year zero coupon bond with redemption value of Z. So there's my price. And we know that this must equal 9697. And because we know that that is the price of the liabilities. And as I just mentioned, well, the price of the assets has to equal the price of the liabilities. All right, so that's good. The second thing I need is I need the Macaulay duration of the assets to be equal to the Macaulay duration of the liabilities. Now, you may want to think about this as a portfolio duration. It doesn't really matter because we don't know the prices of these anyway. I'm not going to get into that. We don't know the prices of the assets anyway, so I'm just going to do this the usual way, which is, let's do this. So let's say Mac D, the Macaulay duration of the assets, using the formula I mentioned a moment ago. Convince yourself this is true. This is not too confusing. This is 5. Well, actually, I didn't write down the Macaulay duration, but hopefully you know what Macaulay duration is. Shit, do I need to write that down? I'll write it down in a second. So I have 5x v to the 5th plus 15y v, sorry, I'm skipping that one, plus z, yeah, plus 20z v to the 20 divided by the price of the assets. The price of the assets is this. I'm just going to write it out to make sure we're clear. Here's the price of the assets. And that must equal, okay, this is the Macaulay duration of the assets. It must equal the Macaulay duration of the liabilities, which is 15.24. So it equals, again, it equals MACDL, Macaulay duration of the liabilities. Now, this formula, I'm not going to write it down, whatever. Find it. This is not confusing. This is the definition of Macaulay duration, okay? All right, now what? Now, I pretty much want to simplify things, but I guess I'll write down the third aspect. The third aspect, which is the convexity. So now I need the Macaulay convexity of the assets, and that is equal to, in this case, using the formula I just used, it's equal to 25 xv to the 5th plus 400 yv to the 20 divided by the price, divided by xv to the 5 plus, why am I using y? This is a freaking z. Goddamn letters, this is a z, right? This is a z v to the 20. That equals the Macaulay duration of the liabilities, 15.24. All right? Mac C L, Macaulay duration of liabilities. These are the situation to deal with. We can already make some substitutions because I have the price. The price is equal to this, so just replace these prices with that. Solve a system of 2 equations, 2 unknowns, and let me show you what I mean. So now, let's go ahead and do that. This is just annoying. I don't have enough space, but let's go ahead and do this. Let's make this work. All right. So let me give myself some room. Let's just get rid of everything. Everything is at 7.5% interest. All right. So I have the following. I have my price this is what I'm going to have. So let me just, I forget everything already. So this is what I have. I have the price. Here's my price. Price of the assets. Price of the assets is xv to the fifth plus zv to the 20 is equal to 9697. Then I have, now you want to do some manipulation with the Macaulay duration. Macaulay duration, I had that fraction, but I knew the denominator. The denominator was already the price. So this says that 5xv to the fifth plus 20zv to the 20 is equal to the price of the assets times the duration of the assets. 9697 times 15.24. Hopefully you know what I did there, right? This is the numerator of the duration of the assets. It was divided by the price. The price was 9697. The duration of the liabilities was 15.24, so just do some algebra. Bring the 9677 over here, multiply them. Now I get two equations, two unknowns. We're in great shape. What am I going to do here? What I'm going to do here is I'm going to eliminate a variable. Perfect setup for elimination method, right? I'm going to take the top equation and multiply it by -5. How about? Multiply by -5. Multiply by -5. This will get rid of my x variable. Add these up. Okay, this looks like 15z v to the 20 is equal to, I'm not going to do the computation, it's just whatever, you can do it. What the hell did I get for this? 297.28. Divide by that business. Okay, this gives you z is equal to 28120.004. I hate the whole rounding thing for this test. It's so annoying. Now think about it for a second. You need to step back and do not make this mistake. Do not freak out and say this doesn't match up with one of the values that was given. The question asks me basically how much to invest. How much do I need to invest in these bonds, right? Right? So you need the price. This is not the price of the 20-year zero coupon bond. What is the price of the 20-year zero coupon bond? This is the remember, Z is the redemption value. It's 20 years. That's when it matures. The price of it is literally this value. This is the price. This is the price of what I called, let's call it P sub Z. It's the price of that the 20-year zero coupon bond. So what am I getting for this? P of Z, the price of the zero coupon bond, is equal to 6619.8. Excellent. Do some back substitution, find X. The redemption value, so blah, 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 you can do it. The X, which is, again, this is the redemption value of the 5-year zero coupon bond, is 4417.69. Again, don't freak out. That's not one of the values given, right? Here, I found X, right? What's the price? Oh, it's just this value, right? And again, by the way, I'm using I erased it. Where the hell? The interest rate is 7.5%. All this is underlying is that I is 7.5%, right? So keep that in mind. That's how I'm getting that value, right? So this right here is the price of the 5-year zero coupon bond. That's the redemption value. How do I get the price? I discount it by V to the 5. P sub X is 3077. The price of my 5-year zero coupon bond is equal to 3077.18. Whatever. We could round more if you want, but whatever, that's what I get. So now, what do we need then? What do we need then? That takes care of, actually, if you look at the values, the options here, this points to option A. Now, do we just go with option A and say, man, we're done, this sucks anyway, I want to be done with this test, right? I just want to get it over with. We just do it and we're done? No. You need to check another requirement, because here's the thing. You could have another option that satisfies the first two criteria. This satisfies the first two criteria, right? This says that the price of the assets equals the price of the liabilities. Furthermore, it says that the duration of the assets equals the duration of the liabilities, but we need to satisfy the convexity requirement. There could be another option that satisfies both of the two. How do we know it's not that one? So I need to go through this actually. I need to make sure the convexity actually follows as well. Let's do that real quick. I wrote down the convexity, the Macaulay convexity a moment ago. Let me write it down once more, because we need to check that the Macaulay convexity of the assets exceeds the Macaulay convexity of the liabilities. Now, let me just write that down. So let's see, Mac C sub A of the assets. I wrote it down a moment ago, but now I'm just going to put the price underneath, right? The price is the denominator. So this is equal to, well, we had xv to the fifth, so this is 25 xv to the fifth plus 400 zv to the 20 divided by the price of the assets. But the price of the assets equals the liabilities, right? Equals the liabilities. And that was 9697 equals the convexity of the liabilities, the Macaulay convexity, which was 242.47. We have everything. Plug in your x, plug in your z. If you want, you could just plug in the prices, right? Because this piece is the price of the 5-year zero coupon bond. This is the price of the 20-year zero coupon bond. You just plug those in if you like. You have them stored in your calculator. Throw them in there. This is what you should get. You should get that actually, I'm not saying it's equal. Just kidding. Don't say that equal. Just evaluate this. Just evaluate this expression. What the hell do I get for this? This expression I'm getting, I don't even have it on here. Did I erase it? It's stored in my calculator. I'm getting, I think it was 288. Son of a bitch. It was stored in my calculator. Where is it? I'm getting 281. There it is. I did the computation a moment ago. Right? 281. Yeah. 281. Am I done? Am I good to go? Well, hell yeah, I'm good to go. Because they're convexity of liabilities, so we have, so hence, Mac C sub A, which is equal to 281, exceeds 242.47, which is Mac C sub L. Hence, so Reddington immunization is satisfied. When the price of the 5-year zero coupon bond, which I called P sub x, is equal to 3077, and the price of my 20-year zero coupon bond is 6619.8. Hopefully this is very clear to you, and you will now know how to attack a problem like this. Tell me what you think, and to the person who suggested this, thank you. Good question to ask.